So for the second example, calculate the force that will be exerted on the scale in a pony brake test when a 20 HP 1400 RPM motor is operating at full load. The length of the brake arm is 3 feet and the tare weight of the brake is 3.75 pounds. So we have here a pony brake test. What is a pony brake test? So it's the concept behind your electrodynamometer, and as you all know, um, things like those are able to measure the overall torque of a motor. I mean specifically for the electrodynamometer. For the pony brake test, you have here, say for example, a wood that is going to be slightly placed with an offset. So this is your wood around the pulley, which is connected to the shaft, connected to the motor that you want to measure. So if this is now going to be the pulley and this is the shaft, this shaft should be connected to the motor that you want to measure. So for this test, you can actually determine the total torque that is being offered by the shaft of the motor. And it's done by, of course, I'm just going to simplify the diagram. I'm not going to elaborate on it anymore. So technically the mechanism is you're going to have here your lever arm, and at the other end there is going to be weight which is going to be measured. So this weight right here is now going to give you a measurement at the scale. So this is the force measured at the scale. So tendency is if this motor is going to rotate for the pony brake test, there will be a certain force here that's going to cause the motor to stop rotating, and that is what we're going to find out, because once we know that, then we can now determine the total torque being offered by the motor. Oh, I'm sorry, that's not supposed to be the torque. This one is the length of the lever arm there. So technically, if you want to write the equation of torque, the torque right here of the motor should be equal to the force times the lever arm there. But what is now going to be significant here is that the force being measured by this scale is going to include also what we call the tare weight. We have a tare weight here. Oops. So this is force. Oops, sorry. So we have the tare weight is the excess weight offered by your lever arm being measured by your scale. So, which means to say you have to take account of that weight as well. So if you're talking of the force that's going to be representative of the force which tends to rotate this motor, then it must be the difference between the force exerted on the scale and you reduce the tare weight. There. So I'm actually just simplifying already the concept of the pony brake test for us to be able to easily follow. So the the force that's going to be representative of the force which tends to rotate this pulley, or the torque that is now going to be representative of the torque of the motor being measured using this pulley, is going to be equal to the force times the length. Whereas the force that should be used for that should be the difference of the force measured on the scale minus your tare weight. So there. Okay? So which means to say, if we're now going to answer this, since we have 20 HP and 1400, so let me write that down. And 1400 RPM, that's your N. You have also here the length of the brake arm, which is 3 feet. And what else? The tare weight, which is 3.75. This must be in pounds already. There. So the question now is, what is now going to be the force that will be exerted on the scale? So we are looking for the F scale. F scale. So before we can solve for the F scale, we must know first what the torque is, right? And how do you solve for this torque? That is now where the equation from your notes come in. So we have here the equation for the output power of motor available at the shaft, which is equal to 2 pi st or nt divided by either 33,000 or 44,760. I'm sorry, this must be 44760. Kindly take note of this. This is very important. So 33,000 if it's in English, or 44760 if it's in standard metric system. Okay? So for our case, we'll be using 33,000. The output here is the output power of the motor in HP. So going back, if we substitute, let me write first the equation. So the output power in HP must be equal to 2 pi nt. We are in English, so this must be divided by 33,000. If we are in English, the torque here must be in pound-foot. So HP's 20 is equal to 2 pi. Speed is 1,400. Torque, we do not know yet. Divide that by 33,000. The torque happens to be, these are calculators, 75.0302. In the pony brake test, this is equal to the force exerted on the scale minus the tare weight times the lever arm. So equate that 75.0302 should be equal to the force exerted on the scale minus the tare weight, which is 3.75, multiplied to the lever arm, which is 3. And this is now going to give us the final answer. Divided by 3 plus of 28.76. This must be in pounds. And there you go.